All right, this is for our Math 8 class, excuse me, finding the volume of a cylinder, a cone, and a sphere. So I'm going to just show you again how to set this up. It is one of those things to where if you know the formulas, it is what we call a plug and chug, meaning you're plugging information and you're finding the solution based on the information that you have and what information you're trying to find. So for a cylinder, so let me back up. First of all three of these shapes, a cylinder, a cone, and a sphere, all have something in common. And if you look closely at it, they all have one shape in common, and that's the circle. So they all have a circle part to it. And so when we think of a circle, you will see this pi, and you'll need the radius. So we'll talk about that. But all a cylinder is a circle stretched out. And so last year, the year before, you learned the area of a circle. And the area of a circle, the formula for that is pi r squared. Well, if you find for the cylinder, the area of this circle, which is the base of the cylinder, this is why it's a capital B, it's the base of that cylinder times the height. So I always talk about in math, be careful with your letters. Don't change the way it's written, because an uppercase B in math and geometry means different than a lowercase b. So the uppercase B means you found the area of whatever the base is to that shape. This base is a circle. So this is the overall equation to find the volume of the cylinder. So when you see problems like this, first of all, I want you to read it. Sometimes they're not in pictorial form like this. They're in the problems or word problems. So you have to decide what type of shape you're dealing with. This one flat out tells us a cylinder has a radius of 4 centimeters and a height of 40. Find the volume. I am making you write the equation. I know it's right there, but on your test, you have to have it memorized. So you want to write it out so you kind of ingrain it into your memory without even realizing it. So volume equals pi times r squared times the height. And so pi, we are going to use 3.14 as our pi. I know in your computer program they wanted you to use 3.1416, but we're going to go ahead and use 3.14. So your volume equals 3.14. I'm going to represent multiplication with parentheses. Radius, now this is the radius is 4. Remember, the radius is halfway through the circle. So the radius, 4 squared, times your height, which is 40. This is exactly what I want to see. You have to keep your work very straight, very easy to follow. You won't make mistakes. You want to make sure then you square this 4 first. Be careful. When you square 4, it's 16, not 8. So you got to be careful. Again, I have not even touched a calculator. If it's a number that you need to square, that you need help squaring with calculator, that's fine. But notice I have all my numbers right here. Now you can grab your calculator, and this is all multiplication. So 3.14 times 16 times 40 equals my volume of that shape. Notice it's 2009 and 6/10. I don't know if you can see that. And 6/10, that's fine. I want you to round to the nearest hundredth if it goes further. But round to the nearest hundredth, but that one just drops off at tenths. That's fine. And then centimeters cubed. Volume is always cubed. It's 3-dimensional. Area would be 2-dimensional. And then just if you need to find the radius, that would be a 1-dimension. But volume, when you find it, it's always cubed. Okay, so that's your cylinder. Cones. Your formula for the cone is volume. No, first of all, this is a cone. So 1/3 pi r squared h. What do you notice about the two equations? The only difference is that this is 1/3 that same equation. So what does that tell you about a cone? That tells you a cone is 1/3 of a cylinder. How many cones would fit into a cylinder then if a cone is 1/3? I know you're all shouting 3, so good job. All right, so we're going to plug in here. So a cone, now careful. This is what many of you are going to fall for. It says the diameter of 8. So if the diameter is 8, we talked about this before. If the diameter is 8, what's the radius? And that's 4. So be careful because the diameter is 8. So volume equals 1/3 pi, use 3.14. The radius is 4, and the height is 40. Again, so I'm going to use 1/3. And I'm going to talk about how you can use your 1/3, but 4 squared is 16. times 40. Do not put in your calculator 0.3 for 1/3, okay? Because 3/10 is not the same as 1/3. So I'm going to show you how you can do this with a standard calculator like this. You don't need a fancy one that does fractions. But you can multiply all of this first, the 3.14 times 16 times 40, which actually, if you recognize the numbers, we use the same numbers as it's going to be up here. So this is going to be, so it's going to be 1/3 of 2,916. Now, multiplying by 1/3 is the same as dividing by 3. So we can keep that number and divide by 3. So multiplying by 1/3 is the same as dividing by 3. And notice your number's now 66972 centimeters cubed. This should be 1/3 of that since we use the same dimensions. The radius of 4, diameter 8, height of 40, height of 40. Okay. So again, it's a plug and chug. Right now we're all finding the volume. We're going to work again tomorrow on how, or another day, on how to find the radius or find the height. And you just go backwards if you plug in what you have. All right, last one, sphere. Okay, now look at your sphere. The sphere cylinder is a little different formula. So the formula for this is 4/3 pi r cubed. So you got to be careful with this. So your sphere is like a basketball, volleyball. Somebody talked about a globe. Somebody said eyeball in class today. So you got to think about a sphere. So again, now estimate the volume of the air in a beach ball. It doesn't tell us it's a sphere, but if you know anything about a beach ball, when you blow it up with air, it turns into that ball form, the sphere. So 4/3 pi r cubed. Now the volume has the diameter of 12, so be careful. The diameter is 12, so we need the radius, which is 6. Okay? So we need the radius of 6. So we have 4/3 times 3.14, 6 cubed. Now you can use that yellow cube and square root sheet that I gave you, or on your calculator. Now this one doesn't have a cube key, but 6 cubed means you're taking 6 times 6 times 6. Now if you have one, I think I took this from a student. Some of them might have x cubed, or you might have the x, either you have a key that looks like this, like the y to the x power, or x to the y power. You can use that. That's hard to see. You can use that too. But you put in the number 6, hit that key, put in the number 3. Otherwise, you could just do 6 times 6 times 6, which is 216. That's 216. Now, how you work this, don't change this to 1.3. That's not the same. You can multiply all of this across here first and then divide by 3. So you can multiply by 4. So I'm going to keep my 216 in my calculator. I'm going to multiply then by 3.14 times 4. So I have 271296 divided by 3. And again, I'm writing all this down. Anything you're typing in the calculator, you better have written down. So I can follow what you're doing. You're only using the calculator to compute. You're not using the calculator to write for you. So now divided by 3 equals 904.32 and inches cubed. Yeah, just making sure that I did that right. So 904.32 inches cubed. Okay. So these you're doing on your own. I want to warn you about this problem here. Be very careful. You can tell it's a cone. 13 is not the height though. You need to find the height. Now what did we just do to find that height? You need to find, this is the Pythagorean theorem. So you need to find that height. So you know the 13 is your hypotenuse. That's opposite of your right angle. So you need to find that height of that cone. So make sure you do the Pythagorean theorem to find that. Okay, so you have to find the height of that cone. So be careful there. Okay, so the rest of this, you want to look at it, centric, whatever it's called. Anyway, so look at the type, watch your diameter, snow globe. Now assume the snow globe is completely a sphere, not one that's just half, which that's a great problem to have, but so I want you to practice that. So when you get that, if you've been gone, but that's how, again, how you solve those type of problems. We'll look at when you're given the volume and you have to find the height or the radius. But thank you.